And we are back. Hello everyone, welcome back to 5 Minutes Code channel where I will be explaining the solution of every problem of lead code and geeks for geeks within less than 5 minutes. So without wasting time, let's get started. So today's problem is aggressive cows, which is marked as a medium level problem. Let's find out what we will be given into this problem and what we have to do. So basically we will be given one integer array stalls and an integer k. Okay, so these stalls basically are the shop. So if you know stall is basically small shop or yeah. Okay, so what does this stalls mean here? So if you will mark, suppose there are one unit marks given. So 1 unit, then there is 2 unit, then there is 3, then there is 4, then there is 5, then there is 6, then there is 7, then there is 8, then there is 9. Okay, all right. So what stalls array defines is basically that there is one shop at one index. Okay, so let's say yes, y, I will mark y here. After that, there is one shop at two index unit 2 unit 2 kilometer, whatever you want. Okay, 4, then there is shop at 4 unit, something like this. Then there is one shop at 8 unit, then there is one shop at 9 unit. Okay, all right, these are the stalls. And now what we have to do, basically this k is equal to 3. K is basically defining the number of cows. K is basically defining the number of cows. Okay, all right. So if we will read this, your task is to assign stalls to k cows such that minimum distance between any two of them is maximum possible. Okay, what does this mean? This is a very confusing line, I will say. So I will request everyone to please read it once again as well. So I will let me tell you what does this mean. This means that there are 5 stalls, you can say. One is 1 unit, then there is another one at 2 unit, then there is another one at 4 unit, then there is another one at 8 unit, then there is another one at 9 unit. Okay, all right. So we have to let's say assign cows at each unit. Okay, assign few cows at each unit. So suppose I will assign one cow at one index, another cow at 2, and another cow at 9. Okay, all right. In this case, what is the minimum distance between two cows? What is the minimum distance between two cows? That is 1. That is 1. Okay, all right. But what we have to do, we have to maximize the minimum distance. We have to maximize the minimum distance, which means we have to place cows in such a way that the minimum distance between two cows is maximum. Minimum distance between two cows is maximum. Okay, all right. I hope problem statement will be pretty clear to you. So if let's say I assign one cows at 1, another cow at 4, and another cow at 8. Okay, all right. So what is the minimum distance between two cows here? This is 2. This is 2. Okay, or 4. One is at 1, another is 4, so it is 3. 3. Okay, all right. And after that, if if I will, let's do place something like one cow at 1, another cow at 8, another cow at 9. Okay, all right. In this case, what is the minimum distance between two cows? That is 1. Here it is 1. Okay, all right. So what we have to do, we have to maximize the minimum distance. Okay, all right. So what you can see here is whatever I can try, if I will place one cow at one unit, another cow at 4 unit, and another cow whatever 8 unit or 9 unit. So what is the minimum distance? 3. Okay, so you can see that minimum distance cannot be maximized than 3. Minimum distance cannot be greater than 3. So we will return 3 as our answer. We will return 3 as our answer. Okay, so this is what we have to do. I hope it will be very clear to you as well. So if you will see another few problems. So here you can see that, let's say 10. Okay, I'm taking the time to properly explain it to you so that it becomes crystal clear to you. Okay, so one cow. Okay, so first of all we will solve this stall array because this is in unsorted, not sorted, and we need to sort it. Okay, so first cow is at 1 unit, another cow, oh sorry, another stall is at 2 unit, another stall is at 5 unit, another stall is at 7 unit, another stall is at 10 unit. Okay, so stalls basically units. If you see a graph, you can see like every square is marked as a unit, so you can take something like that here as well. Okay, all right. So now we have 3 cows. We have 3 cows and we have to place it. So how we can place it? Now let's suppose one cow I place it this point, one cow I place it this point, another cow I place it at this point, another cow I place it at this point. Okay, all right. So what is the minimum distance? Minimum distance is these two. Okay, all right. Can we maximize this minimum distance? let's see. So if instead of pointing another cow at 7, I point it at 10, so the distance between these two is what? 5. The distance between these two is what? 4. So minimum distance is what? 4. Okay. And now we will see how much, no matter where we will place the cows, the minimum distance will always be 4. We cannot make minimum distance more than 4. Okay. So at last we will simply return 4 as our answer. I hope the problem statement now it will be crystal clear to you. And now we will move on to the approach part. How are we going to approach this? Okay. All right. So basically one one way is to use a recursion type of thing to always place one cow, like try to place cows at every stalls. So if you will see, there is one stall here. Let me do once more. I will actually deleted it. 1 2 4 8 9. Okay, all right. So first cow, I will try to place it at 1. After that, another cow, there will be 4 choices for me. I will try to place it at 2. Then another cow, I will try to place it at 4. Minimum distance will be 1. After that, I will again recursively move another cow from 2 to 4, and then I will try to place it at 8. So here minimum distance will become 3. In this way, we have to try all the permutations. Okay, all the permutations, and the time complexity will be very much. It will be in polynomial time complexity, but we don't need that. Exponential, sorry, it will be an exponential. Okay, but we can minimize it. If you will see this very clearly, if you will see this array, you can say that the minimum distance, what can be the minimum possible answer? What can be the minimum possible answer? That is 0. Minimum possible answer is 0. Why? Let's say I place one cow at one unit. I place one cow, and another cow also I place it at 1 unit. We can place it. Okay, so at that point the minimum distance will be 0. Okay, all right. Now what will can be the maximum distance? What can be the maximum distance? Suppose there are only two cows. First cow I will place it at 1 unit. Another cow I will place it at ninth unit, the last stall. Okay, another cow I will place it at last stall, first stall and last stall. In that case, minimum distance will be what? 8. Okay, so now I think everyone has got the what can be our minimum and maximum answer. Minimum answer can be 0. Maximum answer can be array last index, array last element minus array first element. That is 8 for this 8. Okay, all right. Now can we use binary search here? Can we use binary search here to find out uh, to get some minimum distance and try to check that if it is a possible distance or not? If it is a possible distance, we will move to, let's say, more minimum distance, like maximize it. Otherwise I will decrease our mid. I think you guys are able to visualize what I'm saying. Otherwise, what I will do, if our minimum distance is not possible, minimum distance is not possible basically means we are not able to fill all the cows with this minimum distance. Okay, so in that case, what I will do, I will decrease my minimum distance. So decrease, increase, I think everyone knows. To increase it, what I will do, low is equal to mid plus 1. To decrease it, what I will do, high is equal to mid minus 1. Okay, all right, and this way we can try. Okay, so let's suppose 0 and 8. So what will be our mid? 4. What will be our mid? 4. Okay, all right. So what I will do, first cow I will always place it at first unit. First cow I will always place it at first unit. Okay, all right. So 4 mid is equal to 4 here means there will be at least 4 distance between two stalls, two cows. There will be at least 4 distance between two cows. Okay, all right. So can I place another cow at 2? No, I cannot place. Okay, after that, can I place another cow at 4? No, I cannot place. Why? Because uh, there should be at least 4 unit distance. Okay, but if I will place it at 4, 1 4, there will be only 3 unit. Okay, so I will not place it at 4 as well. After that, next stall is at 8. Can I place my cow at 8? Yes, because minimum distance for this should be 4, which is our mid. Okay, after that, another cow, can I place it at 9? No, because the minimum distance should be 4. Okay, all right. So now after that, my array ends and I can only place 2 cows. I can only place 2 cows. Okay, so we have to decrease our minimum distance. We have to decrease our minimum distance. Okay, all right. So in this case, what we will do is I will simply do uh, high is equal to mid minus 1. So high will become now 3. High will now become 3. Okay, all right. Let me quickly delete all this. Okay, all right. Moving forward. Now what will be our mid? 0 3. It will be what? 1. Okay, so now we can say ki mid is equal to 1, so there should be at least one distance. There should be at least one distance. And for now, our possible answer is 0. Our possible answer is also 0. Okay, all right. After that, first cow, I will always place it at first unit. Another cow, can I place it at 2? Yes, because minimum distance is mid here. Mid is equal to 1, so yeah. Another cow, can I place it at 4? Yes, I can place it. Now, what will be the minimum distance? What will be the minimum distance here? 1. Okay. All right. So, I can simply place all the cows. I can simply place all the cows if the minimum distance is 1. Okay. So, now 1 is our one answer. 1 is our one possible answer. But whenever I can place the cows, what I will do? I will increase the limit. I will increase the limit. How can I increase the limit? So, low will become equal to mid plus 1. That is 2. Okay. Low will become now 2. All right, let's delete this again. Guys, I think I'm explaining it very slowly, so it will be becoming very clear to you as well. Okay, all right. After that, again, 2 and 3. Min is 2, max is 3. So what will be the mid? Mid will be 2. Mid will be 2. Okay. Again, we will see first cow, I will place it at 1. Another cow, I cannot place it at 2. I can place it at 4. Okay, all right. Another cow, can I place it at 8? Yes, I can place it at 8. Okay, all right. Now all the three cows are placed. All the three cows are placed. So 2 can be our answer. 2 can be our answer. Okay, all right. Now again, if 2 can be our answer, I will increase the limit. So 2, now low will be equal to mid plus 1. That is 3. Okay, all right. So now high is 3, low is 3 as well. Again, I will see if I can place mid will be 3 as well. Again, I will see if I can place all the cows with 3 minimum distance. So first cow at 1, another cow at 4, another cow at 8. Okay, all right. So 3 can be our answer as well. I will update my answer to 3. Again, what I will do, again, low will be equal to mid plus 1. So low will now become equal to 4. So at any point, if my low will become greater than high, I will simply break and I will simply return my answer. I hope it will be very crystal clear to you how we are doing all these things. Now, the only thing which you will be very curious to know is how we can check if we can place all the cows with minimum distance of mid. Okay, so that I will be explaining in the code as well. So now let's move on to the code section. But before that, if you have loved the explanation, please don't forget to subscribe the channel and like the video. And I have made a very cool Chrome extension for you. That link is also in the pinned comment, so sure, download it. It's completely safe. Okay, all right, now let's move on to the code section. First of all, what I will do, if you remember, first step I told, because the stalls are not sorted, what I will do, I will simply sort the stalls. Arrays.sort stalls. Okay, all right. After that, let me take one variable, n is equal to stalls dot length. Okay, all right. So if you remember what I told, what can be our minimum answer? Minimum answer, low can be 0, because I can place 2 cows at the same stall. At that point, the minimum distance between them will be 0. Okay, all right. What can be our highest distance? High can be anything like stalls last index minus stalls first index. Okay, all right, that can be our answer. And after that what I will do, let's say my answer is also equal to 0 for now. Okay, all right. After that, what I will do, simply use a binary search while low is less than equal to high. Okay, first of all, what I will do, I will calculate the mid. So int mid is equal to low plus high divide by 2. Okay, all right. After that what I will check, I will check if minimum distance is this mid, can I place all the cows? If minimum distance is this mid, can I place all the cows? So what I will do is, let's say there is a function is possible. Okay, which is accepting a lot of things. First one is mid, like minimum answer. Another one is k, number of cows. Another one is this stalls array. Okay, all right. So if it is returning true, it means mid. If mid can be our one answer. Okay, all right. So what I will do, I will simply first of all do answer is equal to mid. And second thing, now I will increase the limit, because mid can be our answer. So can I say, like, if there is can be anything greater than mid which can be our answer? If you remember, I have already explained this using dry run. So in that case, what I will do, low is equal to mid plus 1. Okay, all right. Otherwise, if it is not possible, it means I have to lower the limit. And to lower the limit, what I will do, high is equal to mid minus 1. Okay, all right. And at last, what I will do, I will simply return res here, answer here. Okay, all right. Now we just have to write one is possible function. So let's take static boolean is possible, which will be expecting int mid. and second thing will be int k, and third thing will be int stalls. Okay, all right, three things are there. After that, what I will do, first cow, let's say count is equal to 1 as of now. Okay, and last stall which I have taken is, will look, first stall, if you remember, first stall I will always put my cow, first stall I will always put my cow. So last cow, if you, I will take something like last cow was placed at stalls of 0. Okay, all right, and after that what I will do, I will start from first index, I is less than stalls dot length I plus plus, and look, mid should be our minimum answer. Okay, so what I will write is, if stalls of I minus last cow is greater than or equal to mid, it means I can place another cow. It means I can place another cow. So count will be increased in that case. Okay, count will be increased. Now last cow index will be what? Last cow index will be equal to stalls I. Okay, all right, so these two things I will do here. And after that, look, if my all the cows are placed, if my all the cows are placed, how can I know if my all the cows are placed? If count is greater than or equal to k, it means all the cows are placed. I will simply return true. Otherwise, at last, it means I've come outside and still some cows are remaining, I will simply return false. Okay, all right, so yeah guys, that is it. Let me submit it directly and check if it is running or not. It's a very long video. I hope you have truly enjoyed it, and please subscribe the channel and like the video, and download the Chrome extension as well, because I have made it with too much effort. And yeah, I'm going to see you again tomorrow. Till then, keep on coding and bye.